In this video, we will look at class relationships. To design classes, you need to explore the relationships among classes. The common relationships among classes are association, aggregation, composition, and inheritance. We will introduce inheritance in chapter 15. Now let's look at what is association. Association is a general binary relationship that describes an activity between two classes. So here we have this student courses. Student takes a course. Faculty teaches a course. This is association. So here we have some notation here. This take, you have this a small triangle, solid, point to course. Here's the student text course. You put a label here, describe the meaning. Faculty teaches a course. Also here, you have the numbers here. This is a range from 5 to 60, means a course can have between 5 and 60 students. And this asterisk here means a student can take unlimited number of courses, but that's only hypothetically true. So, here for the faculty, a course is taught by only one faculty. A faculty can teach between 0 and 3 courses. And so let's see how you translate the code for the student, course, and faculty. For student, you can add this method, this is function here, add course, to add a course to this course list. So this is the course list, the student text, all the courses here. And this is the course. For the course, it contains a list of students and a faculty who teaches the course. Those are the methods here. Add a student and set a faculty. So look at the faculty. Faculty has a list of the courses, and the function add a course to the course list. Note, there are many possible ways to implement relationships. For example, the student and faculty information in the course class can be omitted since they are already in the student and the faculty classes. Likewise, if you don't need to know the courses a student takes or a faculty teaches, the data field course list and add a course function in the student or faculty can be omitted. So let's look at the aggregation and composition. Aggregation is a special form of association that represents an ownership relationship between two objects. Aggregation models has a relationship. The owner object is called an aggregating object, and its class is called an aggregating class. The subject object is called an aggregated object, and its class is called an aggregated class. We refer aggregation between two objects as composition if the existence of the aggregated object is dependent on the aggregating object. In other words, if a relationship is composition, the aggregated object cannot exist on its own. For example, here, a student has a name. So the name cannot exist by itself without student. So this is composition. It's a special case of aggregation. So we use the special notation, use the black solid diamond. And this student has an address, and this address can stand alone by itself without student. So that is fine here. Now, in reality, when you design the class, composition and aggregation are treated the same. So when you have this, look, this is the class name, and this is the class address, this is the class student, and student contains the name and the address. So this is how you representing aggregation or composition when you design classes. So for this reason, we don't distinguish aggregation and composition. We're going to treat them the same, and most of the time we just call it a composition, because when you translate into classes, they're all the same. Now, you can also have this is a person. This is the person. Supervisor is another person, so it's to itself, and the person has a supervisor. So you translate into this class here is a person, and a person has a supervisor. Supervisor is another person. And so in this here, a person may have multiple supervisors. So this is a person here. A person may have multiple supervisors. So that is all for the class relationships. Thank you for watching. See you on the next video.